Ni dah rekap belum ni?
Dah. Hey guys, we are from PROJECTRI and this is our video project for fluid mechanics. So to start things off, we will cue to the character introduction scene.
Balik nampak ni.
Now we introduce the king.
Shoot!
Dah. Jalan je tak apa, jangan risau dah
Take
dulu.
one!
Hey guys, my name is Azizan. And have you ever faced a situation where you need to transfer powder from one container to another container with no apparent reason? Well, just like any other normal person, that task is easily achievable by using something as simple as a spoon or even a scoop. But what if you don't want to be just like any other normal people and you would like to take things and put a little bit spice to put it a notch up from any other normal people? Well, we heard you. That's why we are presenting to you guys our group project, the prosthetic equipment to excavate rubbles, or as we would like to call it, Peter. What is Peter, you might ask? Peter is actually a miniature hydraulic excavator built out of cardboards and also scraps. Well, while it does have really cheap materials, it functions exactly as its actual product is. Well, maybe a little bit more inefficient if I do say so myself. Well, you can use Peter to displace sand from one place to another just like the real deal. Let's see. There we go. And done. Now that we've gone through the introductions for Peter, we will now review the products and also parts that we use to build Peter.
Hey guys, I'm Khalid. So today we will discuss about the material that we use to build Peter. There is 4 categories of material, which is the first, structure, mechanism, joint, and tools. For the first category, which is structure, we use cardbox as a body and aluminium tin as a bucket. For the next category, which is mechanism, we use syringe, tube, and ice cream stick to operate Peter. For the next category, which is joint, we use toothpick to join the box to box and cable tie. For the tools category, we use hot glue gun stick, adhesive, and drilling to drill the hole for the fastening process. The last one is we use the black spray as the finishing to color our Peter.
Hi there, I'm Musas Fanis, and now I'm going to further explain on the procedures required in creating Peter. So, first thing first, we want to cut a template with specific dimensions for each part of Peter, such as the arms, the base, literally anything at all. And then we're going to cut the boxes out according to that template that we created earlier. But our main concern is actually the strength of the box. Because we use regular boxes, we actually need to increase the strength and the stiffness of the box. To lift an amount of load, we actually need very strong arms and structure. So how do we actually increase the strength of the boxes? It's actually quite simple. We use not only one, but 2 pieces of boxes. So, okay, here's the trick. If we use only one box, see, it will bend very easily. So if you have like an amount of load, you're probably gonna break Peter's arm. So what we do is, we take ice cream sticks and we glue it on the box like so, And then we're gonna take another box and glue it on top. So by doing this, we're actually gonna get a stiffer box. So now, let's move on to the assembly part. So after we've cut out all the boxes and glued them with ice cream sticks, we would want to assemble them to create pita. So basically how we do that is actually we use different kind of fasteners, and some of them are removable, some of them are permanent. For the removable ones, we actually use cable ties and toothpicks, and as for the permanent one, we actually use adhesive such as glue and all. So now let me show you where do we actually use all these fasteners. So as you can obviously see, we actually use glue to join this base together with this base, and literally the same thing for the whole entire arm. We glue here, actually everywhere. And as for the removable fasteners, we actually use the cable ties to fasten the syringe here. You actually cannot see, but it's there. There's a cable tie here holding the syringe, and that's basically it. We actually use cable ties to fasten the syringe so that it won't move around. And basically, that's how we actually do for all the entire syringe in pita, which you cannot see because it's covered with to make it look more neat. So now let me explain the mechanism of pita. So as you can see here, this is the controller. The syringe that's attached to the controller is actually connected to pita by all these tubes, and the syringe is actually responsible to provide movement to pita at his joints and all. So when the syringe is pushed down, a reaction will occur. See? A reaction will occur which my friend. When the syringe is pushed down, a reaction will occur, as you can see here, and my friend gonna explain it to you later. And last but definitely not least, last but definitely not least, to make pita look less atrocity, we actually spray the whole entire pita with black paint, as you can obviously see here. And voila, you got pita. Or we actually make it worse.
Hi, I'm Rosizati, and I'll be explaining the product objective as well as the working principle of pita. Well, we already know that pita excavates materials, but how does it actually work? Well, using hydraulic system, hydraulic force is generated, and utilizing this force, the bucket is pulled back towards the machine, which in this case is pita. Pita operates based on Pascal's law, which states that when there is an increase in pressure at any point within a confined fluid, there is an equal increase at every other point within the container. Since pressure is defined as the force per unit area, hydraulic pressure can be Since pressure is defined as the force per unit area, hydraulic pressure can be defined as the force exerted on a fluid on a unit area anywhere within the container. In a nutshell, hydraulic systems use incompressible liquids such as oil or water. In a nutshell, hydraulic systems use incompressible liquids such as oil or water to transmit forces from one point to another within the fluid. Thank you.
Boom.
So what do we have here? We actually found a real-life excavator in action. Look at that. What it's actually doing right now is it's forcefully excavating rubbles, and in this case it's actually sand and dirt, using its bucket and arm powered by hydraulic to displace rubbles from one point to another point. Sounds familiar? Yep, that's exactly what pita does, only at a significantly smaller scale. But that does not mean that pita does not achieve its intended purposes. Pita is also able to excavate rubble from one place to another, but only maybe at a little bit tinier scale. Alright, now that we've explained to you guys about the materials used, how to assemble and also the working principle for Peter, we will now explain to you guys and demonstrate how to actually operate Peter. So as you can see on the control panel right here, we have 4 different syringes which are connected by tube to 4 different syringes which is connected to every joint of Peter. So for the first syringe, it is actually connected to the base of Peter. It is responsible for the movement of the boom, which is up and down. Right? So now we have the second syringe which is connected to the syringe that is responsible for the movement on the upper arm. So let's demonstrate here. Yeah, it's not as efficient as we thought it would be. Alright, now for the third one, it is actually responsible of moving the bucket in and out. So we need to lift up the boom first in order, and then movement for the bucket. Yeah. Alright, then lastly for the fourth syringe on the control panel, it is actually connected to this syringe which is responsible for the horizontal movement of Peter, which would go probably like this. No, it's actually disconnected. tak, legit terlepas.
Terjabut.
Tercabut.
Hi, my name is Shafika, and for our conclusion, after struggling multiple times trying to put all the parts together, we were finally able to finish the product. The product turned out to be not very aesthetically pleasing. Also, many things we wanted to do were not implemented in the final product. In the end, we were able to excavate materials forcefully using hydraulic system. If we were to construct another Peter, we would to attempt to include more points of articulation to make this thing more secure and steadier. Lastly, this project allows us to learn how hydraulic system work.
That was a huge drop. Anyway, that's all the time that we have to share with you guys. So throughout the whole video, we can summarize from the introductions to the materials used to the assembly method, working principle, operating method, and also conclusion. So for all the subtopics that we have explained to you guys, we hope that you guys are able to obtain some information that you guys can use it somehow. And before wrapping up the video, we hope that we kept you guys entertained, and from the bottom of our hearts, thank you very much.